Howdy, welcome back. It's tubalcain and it's the next day in this build here on the little Dynamo. And continuing, remember what I did yesterday, bored and faced and cleaned the bottom, and now I'm ready to go ahead and lay out the holes here for mounting it. So what I've done here is located the center already, and then according to the drawing, they call for, and I center punched it there, they called for each hole to be, what was it, well, they're to be 7/8 apart, center on center, so I have this set at 7/16, I believe. Yes. So, let me zoom in just a little bit here. Now, the center punch in the middle here is strictly for my layout purposes. That won't even show up later. But then, did you hear it click in? I just swing a little radius on each end. That's not going to show up very well because this is a relatively rough casting. The surface texture is very rough. They either didn't pack it very hard or something. And then they're to be 1/8 of an inch from the edge, so I will mark them as such. I got to use a little hook scriber to even get in there. This is pretty fine work, like that, and then center punch them like I already did on the other side. Boy, that doesn't show up, does it? There's a center punch mark right there, and another one right there, and those will be drilled 1/8 inch. Pretty tedious work, but enjoyable. And I will drill 4 holes, 1/8 inch diameter here on the Delta drill press. The drawing called for spot facing all 4 of those holes, as you see right here. But with the counter bore that I was going to use for that, which has an 1/8 inch pilot, I didn't even realize I had one that small, there'll just be interference right here. I'm afraid it'll catch and break something or throw the work, and so I'm not going to do that, and that's optional in my opinion anyway. It would have been nice if they would have had a little boss there like this, but of course that couldn't be done because the casting was and pattern was in this position. So that would not have been possible to do in the foundry or pattern making. Well, this piece is essentially done for now. There are 4 holes to be drilled in the end of each, but I intend to, as always, to transfer them from these castings. The drawing shows and gives dimensions for that, but that's not the way I do it. Of course, it could be done that way, drilled in here, and then they could be transferred onto the end bells, but I prefer the former. I've turned my attention to the end bells, and as I said before, there's 2 of them. I think I'll tackle this one first, and really all that needs to be done to these is that they need to be faced and then a little step turn such that they will fit snugly into here and have alignment, and a hole drilled through in the center and reamed 1/4 inch, and then these 4 little bolt holes will be drilled later on, but this is all lathe work, and I prefer to hold this in a 3-jaw chuck, but castings such as this really defy being held. So I've spent about the last hour or so devising a way to do this, and I had a couple false starts. You know, there's one of my failures made out of Delrin. But before I talk about that. Here's the drawing, and you can see that it needs to be faced, looking at this view here, and 1/8 of an inch thick with that tiny little step there that is only 1/32, and of course the diameter is a thousandth less than that 1.333 that we talked about earlier. Of course, I prefer a 3-jaw chuck. This is the chuck off of the Atlas lathe. And to simply put this in there, all the way down, of course, wouldn't work, other than to drill the center hole. I want to do everything in one operation. I don't want to take it out until it's completed. But how are you going to hold it in there so it doesn't cock? Well, I decided to take the time, and a lot of time it was, to make this little block. And this will work for both end bells, with the spokes fitting in these slots. Oh, like that. The hole went all the way through, and this just barely fits into the chuck. It's just a little bit smaller. Matter of fact, it was the same diameter, and I had to sand a little clearance on there, but then again, that's another story. So, with the end bell put in like this, and I do not want the jaws to catch onto these little bosses here, these little projections. So I have to make sure that that is spanned, and then tightening it up, and I'm pushing down here. And this is really easy to do on the bench. You know, gravity is a killer when you're setting this up on the lathe. So that's just snug right now, and this piece is free to move around, and I probably will tap it because it is resting on these 4 bosses. However, there's a little inaccuracy there, so there's still a little bit of this that's wanting to go on. So now I'll snug it up again and install this on the Atlas lathe, and that's the first operation will be to face it off, and maybe I'll do the drilling and reaming first. 1/4 inch ream, because there's little brass bearings that are to be pressed in there. So enough talking, let's cutting. The work is mounted in the 12-inch Atlas Craftsman. I've already center drilled, so this is the 1 size under 1/4 inch. And I'll face it off. And here I am turning that step on there that will just barely fit inside this bore. And I've got a stop set for the depth, because it's only 32nd deep, and I'm approaching the diameter right now. Quite a ways to go. Okay, this might be the last pass. Not quite. About 1,000th or 2 to go. It says 32. Alright, on it goes, and this one is done. I'll take it out. Do not take a piece of work out until you're darn sure that you're done, because there'll be no getting it back in the same. I don't usually take the chuck off, but I'm doing it because I'll set this one up the same way. It's easier to do it when it's flat. I said that before. So there it is. Got just a little deburring to do. And you can see that I've got a little bearing to press in. That came with the kit. Now, it's looking good. Now, doing that in one operation like that assures that the bore here, the hole for the bearing, is concentric with that little ring. And we got a nice fit. The orientation here will be that the bolts will be not in that vertical axis, but about like that. Now, I'm not going to show how to do this because it's an identical operation to this, just absolutely identical. So that'll go real fast because I already have the setup. Then I think I'll press the bearing in, and then I'm going to lay out these 4 holes just rather than by dimensions, because there are certainly dimensions for that, but I just want to lay them out within the center of each one of those little bosses. That's usually how I work. Now, this could also be done on a rotary table, just all kinds of complicated ways, but I don't see the need for that because I'm going to transfer the holes. But you could also drill and tap the holes and all of that on the milling machine on a rotary table, so that this would fit any, let's say mass production. We're going to make 1,000 of these. They would fit. This will be custom fit, and it, you know, I'll mark it and index it because it'll fit like that, but it probably won't fit if I turn it 90 degrees. So but that's the way I like to do it because it's one of. I don't know how you other model makers do it, but that's just my MO. So this is already set up and we're ready to put that in. And I'll do that and go have lunch, and I'll see you a little later. It's time to mask and paint. Well, now that it's painted, you can really see what a rough casting that is on the one side. I kind of wish I would have filled that like with spot and glaze or something and sanded it. I still could do that. Really looks rough and porous, although there's no porosity at all on the inside. Oh well. Next thing I'm going to do is to press these little bearings into the end bells. And these are oil light bearings. You all know what those are. Sintered bearings. If you examine them closely enough, you're going to see that they're very porous and filled with oil. So I'm going to press these in. Now, I had a nice little Famco arbor press. I had it for 25 years, and finally I sold it, of all people, to Keith Rucker, and you might see that in one of the videos. I wish I had it now. It'd be just perfect for that, but that's the only time I needed it in 25 years. Well, they could be pounded in, they can be pressed in, but I think I'll use the drill press. After all, it is a press. I took the time to make this little tool, and it might have been a waste, but it will assure that I press them in straight, and that'll go up in the chuck. Alright, I'm ready to press. Not so fast. What's wrong with this setup? Well, maybe nothing, but there is at least a remote possibility that I would break the casting pushing this way, so I'll flip it upside down. And there I go. That's all this to it. I probably made too big of a fuss about that. And another one. I just feel that's very controlled rather than pounding it in. It's looking good. You know, I may not even paint those end bells. I like the contrast. Well, we'll see. All right, I've got some holes to drill, but I was just checking here to make sure that it turns smoothly, and it does. And there's just a little bit of end play, and we all know you need a little end play. So if that's too much, I'll take it up either with tiny little washers, or I can adjust the bearings just a little bit. You can see this bearing could be pushed back in a little bit if it was necessary, but you know, there has to be end play in motors and generators, but that might be a little excess. All right, next what I'm going to do, put that armature aside. I've already laid out very carefully and methodically those 4 holes and 4 holes here, so I'm going to drill those, and that'll be clearance size for 440. I don't know if I said it earlier, but the smaller screw here is a number 3. That was provided in the kit. I'm upping the ante here to number 40 or number 4s, and they're just a little bit longer. They're both Philister head, so that's what I'm going to use. Just a little less chance of breaking a drill or breaking a tap. I guess I did not tell you how I located the center here, and of course there are dimensions on the drawing for that, but I'm not using the dimensions. I'm just using Randy in the shop, his carbide scriber here, and I just carefully located the center of each boss just by beguess and begosh, by eyeballing it, and then drilled them out clearance size for 440. Then I put an index mark on there, and just by eyeballing it here, I'm making this crossbar here horizontal, and then I marked this one blue, although the blue does not stand out that well in a contrast to the black, but over on this side black, and later on I'll either center punch or file some little permanent index marks so it's always reassembled the same. Because I told you, I talked about mass production here before and interchangeability, and this will not be interchangeable. But one other thing I wanted to show you here, on the Stewart models, they went the extra mile, and in Britain I just think they do this. They use the British Association threading system, but they used a wonderful, beautiful little hex head in their model that are always proportional and look more like you've scaled down a large machine, where a round head or a Philister head or a cap screw, socket head cap screw, doesn't really look all that good on a model if you're trying to scale something. But anyway, that's what I'm using, Philister heads. So here's my time-honored method. You can certainly do it in other ways, and luckily I have a set of transfer punches in the number sizes, and using the appropriate size, I've already oriented this end bell the way I want it on the casting, and I've lined up the blue marks, and I will punch it, always using a brass hammer. There it is, and I will now drill it, the tap drill size, which is a number 43. Actually, I like to use a little bit bigger hole. I don't need a 75% thread. I'm going to double check that, because less chance of breaking a tap. You know, if you got maybe a 60% or 65% thread, I could look that up in the chart, but I'm just, again, beguess and begosh by experience on that, and you can suit yourself. And then what I will do after I drill that hole, and I like to drill them a little extra deep, I've talked about that, so I don't deal with bottoming. And then I will install this with one screw and then transfer the other ones. Why don't I transfer them all at the same time? Because sometimes it might just turn a little bit on me or you, and you know, then all is for naught, you've ruined it. I'm showing you another step here, and I think probably I waste time, but using a little Starrett center punch now, I'm going to deepen the transfer. Then I take it over to my little precision drill press and I spot it. Then I'll take it over to the Delta drill press and drill the actual hole. Yeah, extra steps, I know, but you know, model making is supposed to be fun, so I'm really in no hurry, or I shouldn't be in any big hurry, other than I want to keep the video short enough to where I can retain the interest of the viewers, and I probably already lost some by gabbing too many for too long. I think I'll take the time to explain on the stair chart here about these tap drill sizes. So looking here at 440, where is it here? I got to put my spectacles on. You can see that it calls for a number 43 drill. That's 89 thousandths. Well, I'm going to make it a little bit larger at a 3/32. So 3/32 is my tap drill size. That's what, about 4 thousandths larger than called for. It gives me a little bit shallower thread, but for model making you don't need much strength, and this is the 440 tap. Taking my time so I don't break it. Sighting it in two directions for squareness, and you can see there I got to bring it back in just a little bit. I'm going to go over to the vise and do this, and I'll tap it to the bottom. Remember, I drilled that hole a little bit deeper than necessary.